as the research laboratory and a company. Then we will speak about the modern understanding of the cyber-physical systems, and in particular the case of intelligent transportation. Here the parts will be split in two. At first, we will speak about the practical aspects of the system management and system design. And in the second part, we will actually focus on the theory, and I will share with you some of the theoretical insights, what I have been doing so far within the recent years, and what is actually receiving continuation within Eteronix Research Lab and our team, that what we are doing for the research and so on. So a few words about us, about Eteronix. We actually emerged as the Austrian research and innovation company. Our activity dates back to 2021, and one of the main ideas behind the founding of the company and the idea of making it research oriented was mainly coming from my personal interest and desire to drive further the innovation landscape, both in Austria and in general in Europe and the world. And our laboratory's activity and the company's activity is dedicated to advancing the knowledge and solving complex problems through fundamental and applied research. Just a quick remark here is that I personally was for many years involved in activities of the HiPEAC. Prior to that, by collaborating and doing the research in some pan-European projects, and somehow then later on it was natural desire to extend our collaboration somehow, which led to this presentation and to organization of this webinar. And I hope that in the future our cooperation will emerge further. And returning back to our laboratory activity, so although we are a young research and innovation lab, so we work in the wide variety of the topics related to parallel and distributed systems, to the design of the scalable optimization and computational frameworks. We cover also in our lab the methodology, including exact and heuristic methods for the systems processes optimization. So, and our particular focus touching the intelligent transportation sector at the moment and Industry 4.0 sector, and somehow it's wrapped up together under the umbrella of the digital transformation. As we know, the digital transformation is a very general term, and there are a wide variety of the technology topics, the social topics, and different interaction between technology and social topics. So we, from our side, are trying to cover more technological aspects, yes, with our deep tech experience in these areas, although we are also trying to contribute on our agenda to make our research more impactful in terms of the social impact, and in particular, our recent works were published on the Good IT conference, where we were working on the design of the scalable optimization model for the CO2 emission reduction. And we will actually discuss this in the coming slides. And despite our young age, we have already raised the interest and are cooperating and collaborating in frames at the moment of the national research projects. And at the moment, you can see on the slides some of our partners with whom we are actively cooperating and working, including the UC3M University of Calabria, DITO clubs, the National Science and Research Promotion Agency, which is actually funding our work partially, and we also cooperating with some global partners, like at the level of research at the moment with the Chinese Academy of Sciences and many others. So you can visit our website and the section under research laboratory and learn more about our cooperation partners and the other topics. Returning back to our today's topic, I would like to start with the understanding what is essentially the cyber-physical intelligent system and intelligent transportation systems. On this slide, you can actually see the diagram which was popularized in the works of the Jack Dongara from 2020, and at the moment there are many works are continuing to emerge, and in particular it is a very interesting what is the connection between the computing continuum from one side and the concept of the cyber physical systems. Yes, and in my opinion and in the opinion of the researchers who work in our lab, we understand the cyber physical systems as the environments that comprise highly heterogeneous systems, which mostly follows the notation of the computing continuum, yes, paradigm in general. But in addition to that, we believe that cyber physical systems are also characterized by the complex spatio-temporal organizational structures, varying in nature of workloads. Yes, the workloads of the operational requests, which comes from the complex interaction between the society on the level of the particular individuum from one side, and to another hand, the hybrid cloud-based platforms, which are serving as the backbone for the processing. And the typical applications of the cyber physical systems, as you can see, can include complex social platforms that analyze concurrently various social data and different dynamical aspects of it. And also in particular, what we discussed today is the intelligent transportation systems that process information from the large group of the spatial subsystems that you can see on the right part of this slide. And essentially, there is a huge need to make the complex distributed decision-making process, which we as the laboratory and company are trying to address with our developments, both on the level of the mathematical paradigms and at the same time practical implementations of it in the working software. So that was the quick remark on what do we understand under cyber physical intelligent transportation systems. And now we will proceed to the part number one, which I named under the term of the hybrid cloud architectures, data collections, and the automated scheduling. On this slide, you can see example of the practical ITS architecture which was published in 2021 as the part of my work in one of the research projects, dates back several years ago. And actually here on this diagram, you can see the conceptual diagram of the intelligent transportation systems, which was used for the intelligent transport of the different COVID related protected equipment. And this was highly dictated by the urgent need in 2021. And that was one of the important research topics that we tried to address with my collaborators. And in particular, here you can see the different parts. Yes, the design of the intelligent transportation system includes different parts. So first of all, business processes. Yes, business processes, and I would say in general, the processes that are happening in the social systems, which are integrated tightly with the computational platforms. This is from the one side, and to another hand, we can see the right part of the diagram, which is actually organizing the intelligent framework for the decision making. And somehow, like during the research, we also understood that the addressing of the optimization and the simulation on the large scales is somehow non-trivial and requires the integration, tight integration of not only cloud platforms, but also the data collection techniques and corresponding software stack. So it's not enough to deploy a particular, let's say, cloud platform, which would be doing the required processing, but it's also important to tightly integrate it with the existing business and I would say social processes which are happening. Yeah. And another point that we were working on, this is the work of our collaborators from Johannes Kepler Universität Linz, is integration of the simulation aspects in the intelligent transportation systems. As you can see, there are different processes involved on the different scales. Yes, so when we speak about the transportation, we can essentially speak about the optimization of the processes on the different spatial temporal scales. Yes, for example, on the part A of the diagram, you can see more coarse-grained approach, and on the another two parts of the diagram, you can see more fine-grained approach. And this constitutes actually one of the main challenges, is how to efficiently integrate these processes, first of all, from the perspective of the simulation, because the simulation by itself, the imitational simulation of the processes can take a lot of computational resources and also storage resources. So it's a both CPU intensive process and the data intensive process. From the other hand, from one side, and to another hand, there is an urgent need to make these computations meaningful, because as we understand, the computations, and in particular simulations, should be augmented with the realistic data, and that is at the moment one of the important challenges that is actively in the discussion within our partner network, actually how to integrate this data collection processes and the simulation in efficient manner and scalable manner. So this is one of the important topics that we are trying to address within our work. Yeah. And one of the practical approaches that we have came with is the design of the multi-tier system for the simulation and the data collection and the decision making as well. So you can see on the left side of the slide, it includes the transportation network by itself. This is the very low level of the processes which are happening there. We speak about the different vehicle fleets, self-organization, which is happening on the level of transportation systems. And also, in addition to that, we consider the hybrid cloud environment that is scaling by responding with the growth of the intelligent transportation fleets. So somehow all these two subsystems are interconnecting together under the framework of dynamic multi-scale self-organizing system. So there it includes two components: the monitoring system that is actually making sure by integrating different cyber-physical metrics. It can be the sensor measurements that are coming from the vehicle fleets. It can be, to another hand, dynamic profiling and coarse grain statistics, which you can see on the right part of this slide. There is some profiling data which are being collected on the fly within the systems. And then by integrating those two things, there is also a functioning generalized matching systems which performs recursively a different matching processes within the system, right? So what do I mean with the matching is that usually the optimization of the system-wide processes is very computationally heavy process, as we will see in the next slides. And somehow we designed the approach how to reduce the complexity and make it more tractable through matching reformulation, right? And then this matching system from one side and dynamic multi-scale monitoring collection are being united under the overall platform that allows further working with this data and performing the further scheduling and optimization within the framework in the modular sense. So these are the essentially two tiers. Tier one, which I described before, responsible for the matching and multi-scale monitoring. And the tier two essentially represents the modular architecture that allows further inclusion, for example, of the visualization models and any other online and offline data analysis and optimization. So this was the one of the approaches that we are actively researching at the moment, both from the level of the system architecture from one side, and to another side, we are also working actively on the design of the mathematical models for that. And when we speak about the monitoring and the data collection workflow, it is one of the major points which requires addressing. The problem is that the collection of the data is somehow like a mesoscopic computational and the data collection process, and it includes the different heterogeneous tasks from one side and also heterogeneous nodes. Yes, so the heterogeneity is expressed in the twofold way. Yes, the tasks are heterogeneous because the duration of the, for example, data collection and the data filtration, and then further aggregation results can have an absolutely different values. And also the network by itself is subject to unpredictable perturbation is very difficult to, which are very difficult to predict. And of course, then we have to work with the heterogeneous data collection workflow. And you can see a conceptual diagram that we work with that represents the directed acyclic graph. Many people who are working in the community, they're perfectly familiar. There are many conferences being organized. So that's how we address the monitoring process on the level of mathematics, right? So and then, of course, important, remarkable problem that is being addressed is minimization of the make span for the given data collection workflow. It is essentially important to make the data collection as fast as possible in order to be able to take decisions which are as more realistic as possible to the operational network. Because why do we actually speak here about the minimization of the make span is that many partners of ours, many partnering companies who are operating their intelligent transportation networks were raising concern about the timings for the collected data. So sometimes it is much more important to have as relevant data as possible rather than collecting a precise statistic. So although there is always trade-off, at the moment we have addressed it in the following formulation. And the minimization of the make span is in general an p-hard problem in the strong sense, and incorporates the assignment constraints, it incorporates the precedence constraints, different resource constraints. Yes, some machines in the network, in the cyber-physical network, can perform for example, the aggregation tasks and data filtration tasks, and some of them are essentially not capable for that due to the memory limitation, due to the capacities, for example, cost capacities. Yes, if we have, for example, a very large volumes of the data which are required to process in the hybrid cloud system. So all these constraints are making the problem complex. And contemporary optimization approaches are in the active research in our lab. Just to come back to the slide and make a quick remark, the minimum make span problem is of course being formulated with the absolutely different formalisms. There are a lot of different heuristics that we are at the moment trying to address in our computational stack. For example, many people are familiar with the heterogeneous earliest finish first, with many other policy-based approaches where the tasks are being allocated on the, for example, first come first served basis, or the first come last served basis, and any other more complicated policies. Although one of the main drawbacks and disadvantages of this reduced, let's say, complexity through the policy making is that many times important topological properties and the resource properties and, for example, precedence dependencies of the directly acyclic graph are not catched adequately in this type of the formulations, and contributing to the instability of the system's operations. Yes, we receive, for example, refusals of the tasks and execution and so on. So another approach is somehow the exact approach, where we design the model, mathematical model, which essentially incorporates all these elements together, and then we are looking for the minima of the problem by trying to satisfy all these constraints. So this is classic conventional mixed integer programming approach, yes, where we essentially solving the whole model. However, as I mentioned before, this type of approach is NP-hard problem, and even in the strong sense, meaning that in the general scenarios, you have to check the different resources, and sometimes you can receive infeasible solutions, right, which you cannot use for the further decision making. So that's why it is important to stay on the both worlds. From one side, to provide the tractability, and to another hand, when the dimensionality of the processes allow this, to provide more exactness. Yes, so there is a balance which is required to address in the dynamic states, based on the feedback loop, on what is the current complexity, what is the current dimensionality, yes, of the directed acyclic graph, and what is the current a type of the computational networks. Yes, how many nodes do we have, and how many essentially nodes are participating in the computation. And if heuristics are more or less understandable in the way how they function, the contemporary optimization workflow and landscape is extremely complex. There are many different solvers exist, and there are many different frameworks exist. And on this slide, you can actually see one of the important contemporary optimization framework, a CIP, which is actually spanning a quite complicated process of the solution. I will not stop in the details about it. You can find it in the corresponding paper. But what I'm trying to emphasize on is that incorporation of the contemporary optimization workflows is somehow missing at the moment in the community, and requires a further research and a further addressing. And that's where our research laboratory is also contributing through the design of some open source based frameworks, which allow essentially this complex computation in the hybrid cloud scenarios. Yes, so we help people to scale. We help companies to scale their processes for the parallelization of the optimization in the distributed on shared memory computing environment. And actually, on this slide, you can see one of the results when we tried to use somehow the exact approaches when arranging, let's say, in general, the control process within the network. And as you can see on this slide, for the problem of the directed acyclic graph scheduling in the complex heterogeneous scenarios, the exact methods are struggling to advance. And at the moment, one of the disadvantages is that with some models which are suitable for the heterogeneous scenarios, we receive weak duality bounds, which are actually important property in the optimization process by itself, which basically says how far from the optimality we are. And on this slide, you can see that sometimes it becomes a problem to prove the optimality. Yes, so the solutions essentially reduce to the application of the different heuristics, although these heuristics are much more different from the, for example, policy-based heuristics like HEFT algorithm. And yes, this is somehow what limits at the moment applications of these tools, is that further research is required, how to make it more scalable, how to make it more tractable. And there where we at the moment are working, and we will be also very happy to collaborate on this research topic and see maybe any feedback. I don't know what communities today represented in our webinar, and I will be happy to see to hear from you later on in the question and answer session. What is at the moment your research topics, and how, for example, it could be interestingly synergized with ours. Yeah. And that somehow, like the weak opportunities with the exact method somehow led us to the study of the different two-phase heuristics. And at the moment we have worked on the two-phase heuristics, when in the first phase we are using our generalized matching system to generate the different tasks matching and take into account locality principles and processing of the different heterogeneous nodes. There are possible many open ways how to do it using different approaches, meta-heuristics like simulated annealing and genetic programming. And in the second phase, we actually trying to generate the schedule in the modular way. So the two phases are disconnected in our systems and help to make this process tractable, to receive the minimum make-span solution also in a reasonable time, so we don't actually overcompute, you know, to lose the actually property of optimality. And at the moment, we are also studying even further simplifications of the different list scheduling heuristics, and we work with the serial schedule generations, which run in the polynomial time, providing a very good scalability. The scalability becomes no longer an issue of the algorithm. However, as I mentioned, we receive the reduced precision. So the precision is reducing to the integer domain, although sometimes the processes are very heterogeneous in time, and it requires a further processing on how to actually adjust the horizon and the discretization intervals in order to make this heuristic meaningful. And of course, this heuristics is also not applicable to the general cases of the arbitrary objective spaces. Yes, for example, there are some companies which are requiring also reduction of the costs. And if we also consider addressing of the Green Deal and the reduction of the greenhouse emissions, also sometimes it's very important to address the emission aspects, so energy efficiency. Yes, so and there where we also now actively researching on how to integrate these multi-objective aspects in our system. And that was the part number one, where I have actually highlighted our understanding of the processes which are happening in the intelligent transportation systems. Yes, how do we address it both from the technological perspective of the hybrid cloud systems, and also from the mathematical perspective when we try to, for example, optimize the resource usage and try to perform the scheduling of the activities within the system. And this is at the moment where we are working now. And in this part, in the part number two, I wanted to cover a more theoretical aspects, which are partially incorporated with my own research, with what I am doing personally as the researcher. I have been in the research for quite a while now, participating in in the different research and innovation projects where I mainly, as you can see, was working on the integration of the mathematical approaches and trying to connect it together with the computations. Yes, so it's sometimes not a very easy task and requires a lot of efforts to actually incorporate together this mathematics and computations. And in this part, I would like to speak about how do I see these processes from the perspective of the theory, and yes, what is the now status here. And one of the topics of my personal interest is the working with the different complex networks, and it is now an active research topic also in our lab. On this slide, you can see the visualization of the complex network with the so-called scale-free property. And this type of networks is, in my opinion, especially very important for studying of the cyber-physical processes from the topological perspective. Yes, how the different parts of the network are interconnected together is essentially very important because, as we all know, at the moment, the black box methods based on the usage of the artificial neural networks in general and deep learning are essentially a black box methods, and most of the times the negative aspects of the application of these types of models is the losing of explainability. And this is an extremely important property in the case of cyber physical social systems, right? We speak here about the integration of the social processes, which are inherently complex, and sometimes the black box methods fail. That's why, in my opinion, I see further research also to be focused on the more integration of the different complex networks. And this is the visualization that we have performed in our lab. Actually, you can find a very interesting information in my paper from 2021, where I have worked on the approach, network-based, complex network-based approach to the computing continuum. And inherently, you can see and learn how to use this methodology for maybe some of your research. And important aspect that should be addressed is also, in particular in the intelligent transportation systems, is how to incorporate these complex networks together with the social processes. And this is somehow like, again, reformulation, yes, and we saw already that the similar principles, similar workflows on the level, for example, of the direct vector cyclic graph matching are again occurring here, but now on the level of more a process-oriented level, let's say a social process or the business process. And this is where now my personal active research lies in, and these results you can see were addressing the sustainable transportation process model within the integrated system that I presented before. And here you can actually, we were actually working on the again, design of the different multi-objective optimization model, for short, like integer linear programming model, to address the different cost and sustainability aspects of the transportation network operation. Yes, so if we come back to the network level, so this network was essentially used for the simulation. What would be the workload in the different nodes of the cyber physical system, and then later on this simulation model was used for the prediction matrices, for the transportation matrices in particular, in order to, for example, understand the costs and the failure rates, and for example, the CO2 emission data that we were working with was partially collected from some realistic use cases from our partnering companies. And although simplistic model, still also in PHART was also kind of difficult to address. And there our further research emerged in a way to also design as more efficient as possible, but now on the level of the model formulation. Yes, so we were trying to formulate as efficient as possible multi-criteria optimization model in order to incorporate all these processes together. And here on these slides, you can see the results that were recently presented on the Good IT conference in Portugal this autumn. And one of the important results that we received is that our model that we have designed internally within our lab allows a very fast computation. You can see its magnitudes of the seconds, and from one side, and to another hand, we are able to receive a very good properties in terms of the computational optimization, optimality aspects. So we have the strong duality bounds in that case, and this opens the roads for further Monte Carlo based heuristics and stochastics extensions to incorporate the stochasticity. And this is where we are also working at the moment, and I will be very happy to hear back from the community if somebody else is working on the similar processes, so we could also maybe have some further discussions on these processes. And we have also worked on the preliminary parallelization approaches by integrating some open source frameworks. Although at the moment you can see on the left slide here the parallelization approach, which is based on the parallelization of the branch-and-bound processes. Although at the moment, for the problems that we are facing within our system optimization, are not allowing out-of-the-box application of the particular solvers. And this is, I would say, in general true for the cyber physical systems. It's very difficult to apply any box, let's say, any predefined mathematical solvers in order to make the problem tractable. And this is where now also our research is happening, is that how to make essentially the solution processes as tractable as possible, as energy efficient as possible, and as fast as possible. So it's a classic trade-off problem which we are trying at the moment to address both mathematically and through the design of the practical solution algorithms. So what would be conclusion, and that the future work, which we are hoping to hear back from you, collaboration is warmly welcome here, is to further develop a different algorithms by integrating OpenMP and OpenMPI techniques to speed up the computations. We also are planning to integrate the large-scale simulation to incorporate the GPU accelerators for the topological modeling, for the graph processing, and we also, as you can see, are working actively on the synthesizing of the different heuristics and decomposition methods. And I will be happy to hear back from I think today attendants who may be working on the similar topics. That was the presentation, and I hope it was clear, and also I hope that you maybe have a lot of questions, so we can have a fruitful round of the question and answer. And what would be the takeaway messages from today's lecture is that you are welcome to join our innovation network that we are running within the company, where we are sharing the further interesting updates from also our partners, and interesting invitations for the new projects, for the new research and innovation projects. So please, you are welcome to pass by and register on our website. And for further contact, for any business or research or innovation requests, you can also use our contact form, or you can write directly to our email. So I will be glad to discuss our possible collaboration opportunities.